So today's discussion will be solving exponential equations, and we will see different types of or different methods of or different ways of solving an exponential equations. Now, first, let's look at this. Let's have a look at this property, which is very helpful or will be very useful in solving exponential equations. And this is what we call the equivalence property. And basically what it means is when you have on two sides, when we have b to the power of x equals to b to the power of y, well, if the base are the same for these two sides, then the exponents are the same. Okay, that's what we call the equivalence property. In this case, b has it has to be different from 1 because, well, that's part of the restriction in exponential equations or exponential expressions. Now, this kind of or this property is very, very useful, and we will see what I mean by this. And to see the usefulness of this one, let's have a look at this example. Suppose we have this and we are asked to solve this equation. This is, as you can see, it's an exponential equation. We have 27 to the power of this whole expression, 2w plus 5 equals to 1/3 to the power of 2 minus 5w. And we want to solve or to find the value of w, which makes this equation true. Well, now the question is, which method or how do we solve this? Well, let's see. First, the first thing that we need to do here is let's try to make this base the same. And how do we do that? Okay, I can rewrite this 27 in exponential form. So 27 is 3 cubed. How about the second one then? Because this is not 3, it's 1/3. Okay, let's see. 1/3 is, we can write this one as, well, I don't need the parentheses. 1/3 is 3 to the power of -1. We can write this 1/3 in this form, any fraction. If you have 1/2, this is to the power of -1. Therefore, we have this and we have this. So let's rewrite both of this. So the first one will be 3 cubed. This is just the 27. I will use parentheses now so that we can write this 2w plus 5 equals to, and the 1/3 is 3 to the -1. Again, I will use parentheses, and then we have 2 minus 5w. As you can see, it's going there. We are kind of having similar, the same base, but we need to kind of rewrite this one a bit so that it will be clear. So 3, now we have 3. All these are exponents. So I will multiply them and I will use parentheses so that this 3 will multiply both these terms, equals to 3 -1, again parentheses, 2 minus 5w. Okay. Now, as you can see, we have the same base. Well, so let's apply this now. B, we have the same b. So this tells us that x and y are the same. In our case, x is this term and y is this term. Therefore, if I apply the equivalence property, this implies that 3 times 2w plus 5 equals to -1, 2 minus 5w. We distribute this one, we get 6w plus 15, and then we distribute this one, we have -2 plus 5w. Well, now we have linear equation, and we know how to solve linear equation. So bringing like terms together, we have w equals to -17. Well, the question is, well, does this satisfy the original equation? Is this really solution to this one? Well, let's see. We can substitute this one in here and check if the two sides are equal. So we have 27, 2w is negative 17 plus 5 equals to 1/3 2 minus 5 times negative 17. So this is 27. We have 2 times negative 17 is negative 34 plus 5 is negative 29. And this is 1/3. 2 minus 5 times 17, negative 17 will be 85. And minus times minus, negative times negative is positive. So 2 plus 85 will be yeah, it will be 87. And well, they don't look like the same. They are equal, but yeah, we can rewrite this again a bit. Again, let's write this one as 27 as 3 to the power of 3. So we have 3 times 3 negative 29 equals to 3 times negative 1 again, the fraction. We can write it this way, times 87. So what is 3 times negative 29? Well, that's negative 87. And negative 1 times 87 is 3 times 3 to the power of negative 87. So we have both sides equal. Therefore, this is a solution set. So the solution set to this equation is negative 17. Okay. So this is one way to solve exponential equations by using this, by applying this. But this is not always. We cannot use this one always, because sometimes we can have different base. Here you can have B, here you can have A. In that case, we cannot apply this. This is applied only if we have the same base. Okay, and another way of solving exponential equation is by using logarithms. And by using logarithms, basically we convert the exponential equation or the exponential expression into logarithmic expression or logarithmic equation. And to do so, what we do is we isolate the exponential expression first on one side, of course, and then we take logarithm to both sides. And the logarithm could be any base, but usually we pick the common ones. The common ones are base 10 or base e. In this case, this is ln, and this is just log. Okay, we use log or ln. And sometimes it depends. We can take a different base. Okay. All right. Let's look at this example now. Let's have a look at this example. And here we have 3 to the power of 5x minus 6 equals 2 to the power of 4x plus 1. And as you can see here, we cannot use the equivalence property because we have a 3 here and a 2 here, which are not the same. Therefore, I cannot use the equivalence property. But what we can use is we can convert this one to logarithmic expression. So here we have exponential expressions on both sides. So I can take logarithm on both sides. And the logarithm, as I mentioned earlier, it can be of any base. So in my case here, I will take ln. Okay, you can take log, which is base 10. You can take log base 7, base 3, base 5, base whatever you want. Okay. But usually for example, if you wanted to use calculator, in your calculator, usually the common bases are much easier than the remaining or the others. All right. So here ln 3 to the power of 5x minus 6 equals to ln 2 4x plus 1. Now, what do we have? There is one property, logarithmic property that we have, which is the power property. of logarithms. And that one is if we have log x to the power of a, this is, we can bring this one down here, a times log x. Okay, this is what we call the power property. Therefore, here we have the exponents, and I can use the power property to bring this one down here. Okay, so here we have 5x plus minus 6 times ln 3, and similarly we have 4x plus 1 ln 2. This ln is just a number. Okay, they're not rational numbers because these are forever decimal numbers that go forever, but they are just numbers. They are just constants. They are not variables. And now we distribute this one so that we can bring the like terms together. So we have to distribute this one. So I have 5 ln 3 times x minus 6 ln 3 equals to 4 ln 2 x plus ln 2. So the x variable is here and here, so I will bring them together, and we will have 5 ln 3 times x minus 4 ln 2 times x equals to, we bring this one to the right side, so it will be 6 ln 3 plus ln 2. So these are the constant terms, and this is the variable terms. Now factor out x, so we have 5 ln 3 minus 4 ln 2 equals to 6 ln 3 plus ln 2. Now we divide by the constant, and we get x equals to 6 ln 3 plus ln 2 over 5 ln 3 minus 4 ln 2. So this is what we have. This is the solution to the exponential equation. Okay, so this is another way of solving an exponential equation. And this example, the third one, is a bit different, which means I cannot apply the logarithmic way, or I cannot apply the equivalence property. But we can use a different form or different way of solving this equation. And if you notice, we have e to the power of 2x minus 5 e to the power of x minus 14 equals to 0. And somehow this looks like a quadratic equation. Remember, we have x squared minus 5x plus minus 14. If we have this, for example, this is a quadratic equation. Okay, so we can use a technique that we learned for solving quadratic equation. Now the question is, can I rewrite this one this form? And the answer to this one is yes, because here we can do it like e to the power of x squared, because 2 times x means I can rewrite it this way. We can take e to the power of x first and then square it, and this basically means 2 times x. Okay, minus 5 e to the power of x minus 14 equals to 0. Now you can consider e to the power of x as x here, okay, as one variable, because we have e to the power of x here, e to the power of x here, and here we have x, we have x. So this is just as a variable. Now we can take this one as a variable. And well, basically this is a quadratic equation of e to the power of x. Therefore, just like the solving this equation, what we can do is we find two numbers whose sum is -5 and whose product is -14. And those numbers are -7 and 2. So we have e to the power of e to the x squared minus 2, this has to be plus, e to the x minus 7 e to the x minus 14 equals to 0. And factoring out e to the x, we get e to the x plus 2 minus 7, factoring minus 7, negative 7, e to the x plus 2 equals to 0. So we have e to the x minus 7 and e to the x plus 2 equals to 0. Now from here, what do we get? We get e to the x equals to 7, and from here, we get e to the x equals to negative 2. Now the question is now, are we done? Well, we're not done yet because we have to find the value of x that makes this equation true. And we have two values. So how can we find x from here? Let me write it here. It's the x equals 7. So to find the value of x, we can use the second technique that we used it here for the second example, and that's the logarithmic way, or we convert this one to logarithm. So let's take ln on both sides. Ln on both sides. Now, what is ln e to the power of x? Remember, if we have the same base and the same argument, this is always 1. And this is log, sorry. And ln e means log e to the base e, which means it has the same argument and the same base. So this is just 1. And here first, using the part property, I rewrite this one, e ln e equals to ln 7. ln e is always 1, so we have x equals to ln 7. Okay, so if you have something like e, for example, if you have something like this, it's always good to use ln because you simplify it. If you use ln, it becomes 1. But if I use log base 10, for example, this is not 1. Okay, if I use here log 10 on both sides, it doesn't mean the answer is wrong, but I will have log e to the base x log e equals to log 7. Then I will have x equals to log 7, the base to the over log e base 10. I will have something like this, which is not, which is much more kind of complicated than this one. But in this case, we have just ln 7. Okay, but the answer, both of them, they have to be equal. They are equal. Okay. Now, the first one we found it, but how about the second one? The question is, when we raise a number, if we have exponential function, e, we know this one, this is greater than 0. It's approximately 2.71, something like that. Okay. So if we have 2.7818 something to the power of a number x, will this ever be negative? Whether x is negative or positive, it doesn't matter. Can we make this whole number negative? And the answer is no, because if you put negative here, for simplicity, let's take 2. If we have 2 squared, 2 to the power of x, this will never be negative. It's always greater than or equals to 0. No, greater than 0. Okay. And well, if you have negative, for example, -1, what do we get? We have 1/2. So if x is negative, this to the power of x will be fraction. If x is positive, this whole number will be greater than 1. If x is 0, to the power of x will be 1. So this term will never be negative. Okay, it will never be negative. But here we have negative. E to the power of x equals negative. And to show that, Even if we apply the logarithmic rule like this one, if we convert this one to logarithm, what we get is x ln e equals to ln negative 2. And for logarithm, the domain is greater than 0, right? So, but here we have not greater than 0. So this is not a solution, okay? It's only the first one, ln 7, which is solution. Therefore, here we have, oops, we have ln 7, okay? You can use your calculator to find the approximate value of this one, but that's not an approximate. That's not the exact value. This is the exact value. But if you use calculator, that will be the approximate value. And as with exponential expressions, or as with exponents, we have the equivalence property of logarithms as well. Again, if we have the same base on both sides, then x and y are the same, just like the exponential expression. And we can use this one as well to solve logarithmic equations. And of course, we know we can convert exponential to logarithm. Therefore, even exponential, we can use this one to solve the exponential expression as well sometimes, okay? Because we may get something like this when we convert it. For example, if we have ln x plus ln x minus 8 equals to ln x minus 20, then the first thing that we need to know to do here is, well, we have 3 different ln's. So I need to first combine these two. And how do we combine it? Well, we have the product rule. And what does it say? Well, the product rule basically says if we have ln, I will write it general, if we have log to the base a, x plus, x times y, this is log base a x plus log y base a. So if we had the product of this one, then it's this one. And if you have this one, you can go backwards. So this is what we have. On the left side, we have this. And I wanted to rewrite it this way. Therefore, this is ln x times x minus 8 using this product rule. Okay. And here we have ln x minus 20. So can we apply this one now? Because we have one ln on the left, one ln on the right. And ln means there is base e, both of them. Therefore, we have the same base, and that means x and y have to be the same. So using this property, I will rewrite this one as x minus 8 equals to x minus 20. Now, distributing this, we get x squared minus 8x, and I will bring this one to the other side, minus x plus 20 equals to 0. Okay. And here we have x squared minus 9x plus 20 equals to 0. Now, what are the numbers whose sum is -9 and product is 20? And the numbers are -4 and -9 and -5, right? X minus 4, x minus 5 equals to 0. Therefore, x is 4 or x is 5. Now, the question is, are these two numbers solutions to the equation? Well, let's see. Do they make this equation true? Let's start with 4. If we plug 4 in here, what do we get? ln 4. Okay, that's fine. It's defined. How about ln 4 minus 8? this becomes 4 minus 8 is ln negative 4. Well, negative 4 is not in the domain of a logarithmic function. Okay, this is logarithmic expression, this second term. Again, on this side, 4 minus 20 is ln negative 16. Again, negative 16 is not in the domain. Always this inside term has to be greater or equal to, it has to be positive, greater than 0. Therefore, this cannot be solution. How about if we substitute 5 in here? Again, still this will be negative. 5 minus 8 is ln negative 3. We have ln 5 on this side. And ln 5 minus 20 is minus 15. Again, we have two negatives here. Therefore, this is not a solution. Therefore, the solution for this one is just an empty set. Okay, there is no solution set for this one. So it doesn't mean always, even if we solve it, if we get a solution by following this technique or this method, it doesn't mean always these values they satisfy the equation. So it's a good idea to go back and check whether they satisfy or not, or whether they are real solutions or not. Okay, because sometimes they fail like this one. Okay, and another way of solving logarithmic equation is by, again, using exponential form. So if you notice here, to solve exponential for exponential equation, one of the techniques was to convert it to logarithmic expression. Okay, and another thing is to solve logarithmic equation, then we convert it to exponential expression. Okay, so we use one of them to solve the other one. Basically, that's what we are doing. Now, how do we solve a logarithmic equation using exponential form? And to do this, we isolate the logarithms on one side of the equation, and then we use the properties of logarithms to write the equation in the form of this one. And then we convert this one to exponential form, and we solve the equation. And let's have a look at this example and try to solve it using by converting to exponential form. So first, well, we have these two logarithms, and let's bring them together on one side. So I have 2 log x minus 48 base 7 plus log s x to the base 7. So how do we make this one logarithmic expression? Again, we use the product property. So we have 2 equals to log x times x minus 48 base 7. This is by using the product property. Okay. And now, what's next then? Now here we have one logarithmic expression on the right side, and we have a constant. And remember, if I have log a base b equals to, for example, c, then we can convert this one to exponential form as a. This base, the logarithmic base, will be the exponential base, and this will be the exponent. So this is b to the power of c. And if we do the same, this is the base. So we bring it here, and this will be the exponent. So we have log x man. Oops. We don't need the logarithm. The logarithm will disappear. So we have x minus 48 equals to 7 squared. And we distribute this one, we get a quadratic equation. And we bring this one to the left side so that we get this. Now, we use a technique to solve this quadratic technique, or techniques that we use to solve quadratic equations, because this is basically a quadratic equation. So I have the numbers are negative 49 and positive 1. So we have plus 1, x minus 49. So x is negative 1 and x is negative positive 49. Again, we go back and check these values. X, if we look at this one, we have log negative x. So log negative 1. So x cannot be negative 1 because this is not in the domain of logarithmic function. Therefore, this is not a solution. How about 49? Well, 49, it's in the domain. So we have 2 log 49 base 7 equals to log 49 minus 48 base 7. 2 minus, what is log 49 base 7? Well, this is 49 is 7 squared base 7 log 1. 49 minus 48 is 1. Now, what is this? This is 0. Log 1 is always 0. How about this? Using the power property, I can bring this one, I can rewrite this one as log 7 base 7. And again, as you can see here, we have the same argument and the same base. Therefore, this is 1. So we have 2 minus 2 equals to 0. 0 equals to 0, which is 0, true. Therefore, the solution to this one is 49. Okay. So we've seen different techniques to solve quadratic exponential equations and logarithmic equations. And again, it's always a good idea to go back and check whatever solution you obtain from whichever technique you use. All right. And the next topic is system of linear equations. This is from chapter 5, section 1. And system of linear equations in two variables basically is, well, the first thing that we should know is what is system of linear equations, or what is system of equations in general. System of equations, the name system of equations is basically means group of equations, okay, more than one. So for example, here we have 2 equations. We can have 3 equations together. We can have more than 3 equations. So we use that system term to represent group of equations together. Now, well, if I list the equations like this one, what does it mean? They are separate or they are different? Well, no. When we look at equations as a system of equations, then we need to find solution to each of them, to all of them, okay? We need to find a solution that satisfies all of them. For example, let's try this. Is the first order pair as a solution to this system of linear equation? So why do we call them linear? Because each of them, they are linear, but that's not always true. Sometimes we can have quadratic equations, okay? But for now, for this in this course, we will only learn the linear part. So the first order pair, first what we do is we check this in each of the equations, okay? So in the first one, we get 3 times 2 minus 4 equals 10. This is 6. 6 negative times negative will be positive, so 6 plus 4 is 10. Therefore, It's solution to the first one. How about here? We have 2 plus 1 over 4 times negative 4 equals to 1. 1 over 4 times negative 4 is negative 1, so 2 minus 1 is 1, therefore it's solution. So this is solution. How about the second one? 3 times 1 over 3 minus 9 equals to 10. This is 1. Negative times negative is positive, so 1 plus 9 is 10. So it's solution to the first equation. How about to the second equation? 1/3 plus 1/4 negative 9 equals to 9. This is definitely not, these are not equal. Therefore, this is not solution to the second equation. Now, as you can see, this guy is a solution to the first equation, but it's not solution to the second equation. Therefore, we say this is not solution to the system of equations. Okay? Even though it satisfied one of them, we don't care. It has to satisfy both of them in order to call this one solution to the system. But the first one, since it's a solution to both of them, then this is a solution to the system. Okay? Now, based on the solutions of a system, we have different types of system of equations. One is with a unique solution, something that we have something that they have one common solution. Okay, and this represents intersecting lines. The two lines, the two straight lines, they intersect at one point. So that intersection is what we call the unique solution. That's the solution. That is the ordered pair, because as you may remember, a point on the plane represents, it's a representation of an ordered pair of numbers like this one for x and y. Therefore, I can represent that point by an ordered pair. And another one is a no solution, and that one is if the two lines are parallel. If they are parallel, then there is no intersection, right? If there is intersection, there is a solution. If there is no intersection, there is no solution. So parallel lines, they never meet. They never intersect each other. Therefore, they don't have a solution in common. And such kind of system of linear equations, we call them inconsistent. Okay? The system of linear equations, we call them inconsistent. This is consistent. And the third one is infinitely many solutions. And in this case, the two equations, they meet everywhere. Okay? They have infinitely many solutions, which means the graph of these two equations, they overlap everywhere. Okay? Basically, these two equations are equal. That's what we are saying. For example, if we have x minus y equals to -1, and we have 2x minus 2y equals to -2. So if I factor out 2 here, I will have xy equals to -2. If we divide both sides by 2, we get x minus y equals to -1, which is the same with this one. Okay? So basically, this means if we have infinitely many solutions, that means the two equations are basically the same. They are equal. And such equation, we call them dependent. Okay. Now, how do we solve system of linear equations? Well, there are different ways. Basically, the most common, I mean, the two ways that we're going to cover here are the substitution method and the addition method. And we will start with the substitution method. Now, what does the substitution method mean? Or how do we use the substitution method to solve system of linear equations? So the substitution method, as the name implies, what we do is, because if you notice, we have two variables and two equations. Okay, so pick one of the equations. It doesn't matter, it's up to you. Usually we pick the easier one, but it doesn't matter. So you choose one of the two equations, and you solve for one of the variables. You could solve for y or you could solve for x. Okay. For example, if you pick this one, it's easy to solve for x because x doesn't have coefficient. It has coefficient 1. Therefore, once you solve for one of the variables, then you substitute that expression in the other equation. Meaning, for example, let's take this example. So here we have two equations. You can either pick this one or this one. For me, I will pick this one, for example, because it's easier. So I will write x equals to 6 plus 3y. Or we can rewrite the other way. It will be 3y plus 6. Now, here again, we have x and y. So I will substitute this term, this expression, in place of x here. Okay? Do not substitute in the same variable, in the same equation. Okay? That's a mistake. We have to substitute the value of this expression in place of x here. Therefore, what we have here is 3 times, and instead of x, we have 3y plus 6 plus 4y equals 5. As you can see now, we have only one variable. We got rid of x, and that's the good news, because if we have one variable, we can solve this. We don't need another equation. We can just solve this one, okay, because it's a linear equation. So distributing this one will give us 9y plus 18 plus 4y equals to 5. So on the left side, I will keep the variable term, and that will be 13y. And I'll take this one to the other side. 5 minus 18, that will be negative 13. So y will be negative 1. Okay? And how about x? Well, x is given by 3y plus 6. So we know the value of y, and I will substitute this one in here. So x is 3 times negative 1 plus 6, and that's negative 3 plus 6 is positive 3. Okay? Therefore, the ordered pair is 3, negative 1. Now the question is, does it satisfy the system? Hopefully yes, but let's see. So for the first equation, I take 3 times 3 plus 4 times negative 1 equals to 5. And this is 9 plus negative 4 equals to 5. Well, that's true, because 9 minus 4 is 5. Okay? And how about for the second one? 3 minus 3 times negative 1 equals 6. 3 plus 3 is 6. Okay? And this is right again. Therefore, the solution set is 3 minus 1. Okay? So remember, the solution for this, for a system of linear equations, it's a paired numbers. It's not a single number. Therefore, you shouldn't forget this parenthesis, because the solution, we cannot say 3 and negative 1. It has to be 3, negative 1. That's considered to be just one solution, not two solutions. And another way of solving a system of linear equations is the technique called the addition method, or the method called addition method. And this is, what we do in here is we add the two equations, and we get rid of one of the variables. But to do so, first thing that we need to do is we have to rewrite this one in a standard form. The standard form of this is, we have 2x minus 9y equals to 1. we keep the constant on the right side and the variables here, and doing the same for the second equation. I will bring y term on the 2y equals to 17. Now, if we add these two, well, we have 5 and we have -7. We don't get rid of any of the variables. So what we try to do is we multiply either both of them or one of the equations by a constant, so that one of the variables, you pick one of them, either this one or this one. They will have opposite coefficients. By opposite coefficients means, let's say we multiply by some number to the first equation and this, by another number to the second equation, so that we will get -6x, and the second one will be +6x. We have plus something here. Okay, we don't care about the remaining. So if you want to get rid of x first, to cancel out x, then multiply this by some number, by some constant, and this one by another constant, so that you will have the x will have an opposite coefficient, which is something like this one. So when I add this, we get 0. That's the idea. Or how about if I wanted to do that one for y? I can do the same thing. So multiply this by some number, let's say by multiply the first equation by 2, and you will get -18y, and multiply this one by 9, you will get +18y. Okay, and if you add this one, again you get 0. So that's what we are going to do here. And the question next, you may ask, which one do I pick? Which one do I cancel first? That's up to you. Okay, there is no, it doesn't matter which one you cancel out first. So here, for example, they have opposite sides already, opposite sign already. The only thing is they are not the same number. This is 9, this is 2. So I don't need to change the sign, but I need to make sure that these two numbers are the same. So what I'm going to do is I will multiply this by 2, and I will multiply this by, I guess that's too big number. Let's ignore that one. Okay. I will just cancel out the first term, because multiplying this by 9 would probably be a big number. It will be 100 something. Okay. So let's multiply this by -3. And multiply this by +2. Now, the idea is to make the coefficient of x opposite to each other. Okay, so here we have -3 times this is -6x. -3 times this is +27y. -3 times 1 is -3. We multiply this, all the terms, by this number. And similarly here we have 6x plus 4y equals to 34. Now we add the two terms. Okay, we add the two equations. So -6x plus 6x is 0. Well, you don't need to write this one, but just to show you, this is 0. And if we add this two, we have 31y. And we add this two, we have 31. So divide both sides by 31, we get y equals to 1. Okay, and then you can use this value and substitute in one of this. It doesn't matter which one you pick, and you solve for x. So I will use the first one because the coefficients they are smaller than the coefficients of the second equation, but it's totally up to you. So 2x minus 9, y is 1, equals to 1. 2x, I will take 9 to the other side, so it will be 1 plus 9. So x is 10 over 2, which is 5. Therefore, we have 5, 1. Now, again, you can check this one, and that will be the solution to this system of linear equations. Okay. So there is only one unique solution to this system of linear equations, which means these two, if you graph these two equations, they will intersect at this point. That's the interpretation of this system of linear equations. And another example is we have, this has to be minus, yeah. We have 2x, 2 times x minus 2y equals to this one, and then we have the fraction. And for this one, I have to distribute this one first. So we have 2x minus 4y equals to y plus 14. And the second one, we get rid of the fraction because it's always easier to work with integers rather than fractions. So how do we get rid of this? We multiply this by 6, which is the LCM, right? So what do we get? For the first one, 6 times this 1/2 is 3. So we have 3x. And this is 7y equals to, and that one is negative 2 times 13 is 26. Okay. And first, let's rewrite this one. 2x, bring y to this side, so it will be 5y equals to 14. And 3x plus 7y equals negative 26. And the next is we use the technique. So here you can either use the addition rule, the addition method, or the elimination method. Well, by the way, I forgot to mention that here the addition method we sometimes is called the elimination method. Okay, this is sometimes called the elimination method because we are eliminating one of the variables here. If you see here, we are eliminating one of the variables. That's why it's called eliminating method. So here you can either use the substitution method or the elimination method. I will use the elimination method or the addition method, sorry. I should better use the addition term. So multiply this by negative 3 and this one by positive 2. And we get negative 6x plus 15y equals to negative 42, and that one will be 6x plus 14y equals to negative 252, I think. Yes. And now we add them. So 0, where? Okay. Yeah. So we have 0, and this is 29y equals to, this is negative 94. And then we have y equals to negative 94 over 29. Did I miss something here? Okay, 2x minus 4y, y 14, and this is 3x, 7y, and this is 26. Okay, and 15y minus 42, yeah, think, yeah. Okay. So y is negative 94 over 29, and then we can use one of these equations to simply to find the body of x. So using this, 2x minus 4 negative 94 over 29. Oh, it should be 5 equals to 14. So we have 2x equals to 14 minus 20, 47, 470 over 29. Yeah, so it's a big number. And we have x equals to this number is, okay, let me see, 29 times 14, 6, 3, 8, 1, 1, 9, 2, 6, 0, 4. 406 minus 470 over 29. So x is 66 over 29, right? 64, sorry. This has to be 64 over 29. Therefore, the solution to this becomes negative 64 over 29, comma, negative 94 over 29. Okay, so it's good. I don't know, probably I made some mistakes somewhere here. So it's a good idea to try to look at it, to have a look at it. Okay. All right. So here all the examples that we consider, they have solutions. Okay. So they are not inconsistent. But sometimes we may have equations which don't have a solution, which we call them the inconsistent system of equations. For example, if we have these two equations, their graph is parallel. If you rewrite them in this form, as you can see, they have the same slope, 3 over 4, 3 over 4, which indicates that they are parallel. Because remember, two lines are parallel if they have the same slope. And if you solve them either using addition method or the substitution method, you get no solution. Okay, which means we multiply both sides. We multiply the first one by negative 3, so that to have negative 9x. So negative 3 times this will be negative 9x, and negative 3 times this will be positive 12y, and negative 3 times 6 is negative 14. So if we add these two, negative 9x plus 9x is 0. 12y plus negative 12y is again 0. So on the left side, we have 0. On the right side, we have negative 14, which is not true. 0 is not negative 14. But here, it looks like it's telling us that these two numbers are equal. So if you get something like this, when you try to solve system of linear equations, if you end up with these things, two numbers are equal, which are not equal, then that tells you that there is no solution to the system. Okay, therefore the solution to this one is empty set. And another one is the infinitely many solutions. Suppose we have this 3x plus y equals to 6, and to rewrite this one in if you rewrite this one in slope intercept form, we get negative 3x, y equals to negative 3x plus 6. And again, we have this equation, x plus 1 over 3y plus 2. And rewriting this one in slope intercept form, we get this. As you can see, they are exactly the same, right? Even though here they look different, They are exactly the same when we write them in slope-intercept form. They have the same slope, they have the same intercept, y-intercept, and the graph of these two equations will be exactly, they overlap, right? And if we solve these two equations, if you substitute this in here, you get x plus 1 over 3, y is this 3x plus 6, and if we solve them, we get 0 equals 0, which means they are equal everywhere, at every point. So if you end up with the same number equals to another same number, which is true, then it means they have infinitely many solutions. But if you end up with two numbers being equal, which are not equal in reality, then that tells you that there is no solution. Okay, here there is no solution. Here there are infinitely many solutions. And what is the solution to this one? What are the solutions? How do we list them? Where the solutions are x, y side that 3x plus y equals 6. You can write it this way, because basically this is this line. And the solution to this system is represented by this line, okay? The solutions are, if you plot the solutions, basically that's the line. So you write it this way, we can write it this way. All these, they indicate, or they are the same, okay? One is good enough, okay? All right, so this is all for today, and see you in the next lecture.